This is an algebra review worksheet on rational function graphing. If you don't have this worksheet, please pause this video and I'd like you to go to the Blackboard and print this out. Okay, so I'm going to go through 3 problems relating to graphing rational functions. So the first one is r of x is equal to 2 divided by x squared minus 2x minus 8. And you want to factor the numerator and the denominator as much as possible. So the numerator cannot be factored, so I'll just leave it as 2. And then the denominator can be factored as x minus 4 and x plus 2. Okay, so then you have to answer various questions based off of this. So the vertical asymptotes are wherever the denominator is equal to 0. So if I look at this denominator here and set it equal to 0, and this one set it equal to 0, I get x is equal to 4 and x is equal to negative 2. Make sure you write it as equations. For the horizontal asymptote, let me write the general rule down here below. Right? So for the horizontal asymptote, you're going to find the highest degree in the numerator. I'll call that as n. So n is equal to the highest degree in the numerator. And then d I'll call the highest degree in the denominator. And there will be 3 options. You'll either have the numerator's power that is less than the denominator's, the numerator's power is greater than the denominator's power, or they are equal. Numerator is equal to the denominator. Okay, so if the numerator's power is less than the denominator's, then you have a horizontal asymptote as y is equal to 0. If the numerator's power is greater than the denominator, then there's no horizontal asymptote. And then if the numerator is equal to the denominator's power, then it is equal to y equals the coefficient of that numerator divided by the coefficient of the denominator. Okay, so in our problem, the numerator's power is less than the denominator's, so that means that there is a horizontal asymptote at y is equal to 0. And for our particular problem, there's no oblique asymptote, and I'll talk about oblique asymptote on the third example. Okay, so for wholes, you have to look at any common factor in the numerator and denominator. Any common factor in numerator and denominator. Since there are no common factors, then there are no wholes. So I'll say none on this. The domain are all the possible x values that it cannot be. So generally, it's going to be all of your vertical asymptotes along with any wholes that occur. So for this one, it's going to be all real such that x does not equal 4 or a negative 2. You find the x-intercepts by setting y equal to 0. So in this one here, if you set y equal to 0, then the 2 can never be 0, so there's none. And then the y-intercept, you set x equal to 0. So if you set x equal to 0, it's easiest if you just cover this up. See, here's an x and here's an x. I just cover this up, so then I have the y-intercept at a negative 1/4. Okay, the next thing I want to do is to fill in this truth table. So this is going to help me to figure out whether the vertical asymptote, since I have 2 of them, whether it's going to be going to infinity or negative infinity. All right, so pick points to the left and the right of each vertical asymptote. And so we know we have 2 vertical asymptotes. One is at 4 and the other one is at negative 2. Okay, so I'm going to set it up this way. Here are my x values and then the corresponding y values. So I'll first start off with a negative 2. So I'm looking at negative 2 and a number to the left of it. So that's the notation I'm using, negative 2 to the left of it. And then I have negative 2 to the right of it. And then I'll use the other vertical asymptote, which is 4 to the left of it, and then 4 to the right of it. Okay, so I choose a number to the left of negative 2 and just choose the best number, which is going to be a whole number. And as long as it doesn't interfere with the other vertical asymptote, it'll be okay. So if I choose to the left of it like a negative 3, And I'm going to look at the factored form right here. Okay, so up here, my numerator is always a positive, so I don't need to worry about that. So here, if I put in a -3, it's going to be a negative, negative. So overall, it's going to be a positive infinity. If I choose a value to the right of -2, like a -1, then I have a negative and then a positive. So this is going to be a negative infinity. Okay, 4 to the left of it. So 3, I'll choose 3. So this will be a negative and a positive. So that's going to be a positive infinity. And then if I choose 4 to the right of it, a number like 5, so it'll be a positive, positive. So it's going to be a positive infinity. Actually, I'm sorry. The previous one should be a negative because if I choose one to the left of it, then the first one's going to be a negative. Okay, I need to erase that. So that'll be a negative. All right, now I'm ready to do my graphing. So I'll first of all put in my vertical asymptote. So since I have a vertical asymptote at 4 and a -2, I'm going to place those in. So here's my vertical asymptote. Now I'm going to use dotted line for this. And then -2 will be right here. And then I have a horizontal asymptote at y is equal to 0, so that'll be down here along the x-axis. Okay, next I want to put in my key points. So I have a y-intercept at a -4, 1/4, so that'll be somewhere right about here. And now I'm ready to draw my graph. So look at this truth table. So to the right of -2, so that's going to be in this region, it's going down to negative infinity. So then it's going to go down towards this way. And then to the left of -4, it's going to be a negative infinity. So it'll go down towards this way. And then to the left of -1, it's going to be a positive infinity. And I also know that there's a horizontal asymptote, so it has to kind of ride along the horizontal asymptote. So this region, it's going to do this. And then on the other side, to the positive side of 4, it's going to be positive infinity. And again, it's going to go along the horizontal asymptote. And there you have your graph. And using your calculator, you can check your answer.